All right. Good morning, everyone, and welcome to today's tutorial. My name is Ronell Sicat from the KAUST Visualization Lab. So for today, we're going to have a tutorial on Avizo / PerGeos. And this tutorial came about from just a conversation between me and Ksenia. So Ksenia, thank you for coordinating with the topics as well and some data sets. So we have all the way from France here an expert from ThermoFisher. That's the company behind Avizo and PerGeos. So he will tell us more about Avizo and the recent changes with PerGeos. So again, the session is recorded, but please stay. And if you have questions, feel free to just interrupt and ask. Okay?
Sure.
All right.
Hi, good morning, everyone. My name is Sarawuth Wantha. I believe that some of you already met me or know me, so I also know some of you already. So today, just big news because we just announced that the end of life of PerGeos software. So now we're gonna migrate all the features in PerGeos. Most of them are something that's really important for the oil and gas and petroleum application in Avizo software. And so I'm gonna guide you to how we gonna look at the software, what change, and in terms of application, it's going to be easier for you to use the software. I included slide just in case if someone following online, so you can scan and try to install the software. We also have embedded license there. But later, when it's officially available, so you can just take it to the lab. Exactly. So yeah, that's pretty sure. So the agenda, we're gonna have 2 sessions today and tomorrow. So today we're gonna do introduction also to Avizo, because for some of you might not familiar with Avizo software. So just to understand the principle, the basic behind. So it's really important to get a feeling of how to interact with Avizo software. And then we're gonna jump into PerGeos features. For example, for profile, that it become the new workroom in Avizo software. So we're gonna work on the profile. For example, do core, correct beam hardening with just using the module and then create the core profile and log, and then some reporting. And then we're gonna add some extension that we call simulation. It's already available in also in Avizo, so we're gonna generate the Tetrahedral for finite element analysis. And tomorrow we're gonna work more on modeling and simulation, including for network modeling, absolute probability, and some other simulation. And so for specifically for digital log analysis, we're gonna look at the absolute probability and two-phase flow simulation and some other stuff. But just we will keep it open. So if you have any question and any suggestion, and yeah, we can go through it. And keep in mind, so it's not gonna be the full training. It's just to give you a glimpse of what's going on here. And yeah, hopefully we can have more time to discuss about it later. And probably next year I'll come here again. For the first credit. Yeah, don't be over stressed. So usually when you work with virtual workflow, or even Avizo, you're gonna have the same standard procedure. For example, in PerGeos, if you remember that first you need to load image and then you do image pre-processing. In each step that I listed here, usually in PerGeos, you have to go to different workroom, different tabs. Step 1, you load image, and then step 2, you go to tab of image processing and segmentation and processing and do the compute statistics. So it's quite tedious. And then if people already work with Avizo, you will see that they kind of much better, more streamlined in Avizo than PerGeos. And for example, you can see here when you load data and you go to different workroom in PerGeos, and it's a bit kind of go back and forth. That's why we want to streamline and bring everything back to one dashboard. So we will go through it later on the real practical. And just quickly on image processing theory. I think this is really important to understand this. So if you look at the image, usually when you acquire image, it's going to be, okay, let's say city. What you capture is just intensity, and when you look close enough into the image, you can see that image composed of the pixels. Pixels have different intensity information. So if you talk about 8-bit grayscale. That means they have the value of 2 to the power 8. That means this pixel intensity can vary up from 0, that's completely black, to 255, that's completely bright. So this grayscale variant can go up to 256 value for 8-bit. But you have 16-bit or even 32-bit. So 16-bit you can go up to 64,000 shades of gray, and then if you have like 32-bit, you have maybe billion to billion of shades of gray. So, and when you talk about this shades of gray, it's the meaning of the intensity of each pixel. As you can see here, not sure if you can see my mouse. Yeah, on the area that I hover the mouse or highlight it here, you can see that it's quite dark, and then each pixel have intensity probably between 0 to 10, and then we go to the brighter area, you will see that the intensity of this pixel are a bit higher. We go up to 250, 255 to maximum. So that intensity value of the pixels, so you understand. And what we look at here is just 2D pixels. And when you have 3D images, we call it voxels, so it's 3D information. So you have X, Y, and then the Z. So 2D for pixel and 3D for voxel. And as you can see here, when you just look at each of pixel, you will see that this kind of kernel space, this kind of metric, for example, you want to do any kind of calculation to average. For example, if you see this the center of the pixel in the kernel, and if you look at the matrix that they are connected to the neighboring pixels, so you can see that they have maximum 8 pixels in 2D connected to each other. For example, this is important for image processing. For example, you would like to do filter to smooth or to reduce noise, so you need to average the intensity information between the center pixel compared to the surrounding. So you use this information to image processing. And then, for example, you want to do arithmetic mean, so you can combine all the value of intensity of this matrix 3 times 3. So that means you will get average value, and then you can apply any one to center pixel. You can do this like block by block, like scanning raster, and then you will get a new value and apply some formula to the pixel. We will see that in more detail. Let's see this good example of median filter. Of what we do here, you can see that if you look at matrix of 3 times 3, and you have 9 values. So in the center, we have, for example, we have intensity of 10, and the surrounding have lower value. So you can see that in the center, actually, they have like not in the range of the average intensity. So we apply median, like we apply mean value. So you have all the value, 9 of them, and divided by the 9, then you get a new value of 4, and you assign this center pixel to 4. This way, you kind of averaging the intensity based on the surrounding, and that's why we can see that it's been smoothing, because it's been adjusted according to the surrounding pixel of the neighbor in 2D. And it's the same, because the way we do here, we apply mean filter in 2D space. But if you would like to interpret them at 3D, you can also do it, and it gets more accurate, because you have more neighbor to put this information into account, and when you calculate them in 3D, it's more more accurate. And compared to different type of filters, so if you have box filter, you can see that it just simply just averaging of all the value. But if you have more like arithmetic means or non-local means, so the way they calculate the formula to do this application is more sophisticated. And the difference is that the more formula you apply to this image processing, the feature has been preserved. The contrast and the noise removal is very prominent, as you can see, with non-local means filter compared to the box filter, because box filter is just kind of averaging, and it's not really based on contrast. But you can see that in non-local means filters, we have more contrast, and then remove a lot of noise. As you can see here, in some comparison between different type of filter when you do image processing, just original data, you can see that it's quite pixelated. With median filter, it's quite universal for the so-called salt and pepper noise. So when you have like a lot of grain dots and black and white of the pixel, and you can see applying median filter is really quick and easy to do. Box filter is more like blurring, so you just lose most of the information. As you can see here in the middle of box filter, might lose some small line. If you want to look at crack, for example, small porosity in the rock, you might not capture that with this box filter. And it depends on type of structure you're looking at. So even the best filter might not available, or it's not applicable to your data set. So you have to see which one gives you the best feature. So in Avizo, we always say that if you see it, that you can segment it. If you don't see it like microfactor, it will be difficult as well to segment. So just keep it in mind in terms of segmentation. And again, just to remind you, but you will see later, the interpretation in Avizo, we have 2D interpretation and 3D interpretation. You can see that if you look at 2D and you look at the center of the pixels here, you can see that in 2D you have maximum number of 8, and then if you look at the more larger metric, you can see more number of pixels. But in general, in each of the 2D pixel, you only have maximum 8 number of surrounding neighboring pixels. But in 3D, so you have actually 3 options. You have only the cube of the voxel that are face to face. So you have total 6, and then 8 and 18 and 26, the maximum number of the neighboring voxel that you can use the value of the intensity of each voxel to calculate the average of the data. Yeah, and then some of the operation. So you can see that if you work on some kind of erosion, you can see, as you can see, because we look at the 2D, the way they erode by some certain pixel. If you define you want to shrink or erode them by 1 pixel, you can see some. Here, for example, where my hand mouse over here, after you erode them, they start to open up in shape. The pixel is more cube. And this is how I mentioned on the 3D interpretation. As you can see, if you look at the center of the voxel, so if you want to have minimums of the face-to-face contact of the 3D voxel, you have minimum of 6 voxels that are contacting face-to-face. And you also consider if they have even the edge between the cube contact to the center voxel, you have intermediate 18 voxel, and maximum even the epiphysis of the voxel touch to the center of voxel, so you have one number of 26 compared to the 8 neighboring pixel in 2D. So that we keep in mind when I'll point out in the software itself, so you can get the real feeling when you work on it. And the important morphology operation, so dilation and erosion, they also have different combinations. So basically, the name suggests it already that erode, that give you erosion and then dilation. But if you do the combination first, look at the closing. Closing is on the left, top right, bottom right. The closing operation is that first you dilate the image. After you dilate them, you can see the original image is like this. After you dilate them, so they expand in all direction of the pixel or voxel in 3D. If you would say, you can see, for example, if I would like to dilate this image on the left here, by 1 pixel or 2 pixel, and you can see they start to grow in all direction by 1 or 2, 3 pixels. And then if you combine by dilate it back, sorry, first you dilate, and then if you combine by later you erode it back, so it becomes closing. And the same opposite way, the other way around. So first, if you start to erode the image, so you can see that you shrink the first image input here, then you shrink them, they kind of shrink, and then some of the features have been lost. Especially the thin, narrow object will be kind of losing because you shrink them, you erode them. And then when you grow it back, it becomes so-called the final or open image. So this is very important to understand what is closing and the opening. Just look at the original image. So if you close them, you see the small feature of the pore or hole in the image will be closed. But if you do opening, you can see that all the thin structure or the small island will be removed because of the opening. So we said opening and closing. And just 3D comparison that you can see that if you do dilation or erosion in 3D, you can see the original image on the left over here. After you erode them, then most of the structure has been reduced by the number of pixels. So you can see the example with 3 pixels. And then if you expand them by dilation, you can see the growing in 3 pixels. And in PerGeos, you will see that we need to create a mask because we want to define the area of working. But you will see later that really easy to do. Create any mask to understand what the working space you are working with. And another interesting feature is called fill hole. And in this example on the left, you can see the kind of porosity or the holes inside of these images would be 2D or 3D. And if you apply fill holes or the holes to be filled, and sometimes you have to understand that if you select to fill by XY plane, any holes that are interpreted in XY plane in 2D will be filled. But if you sometimes interpret in 3D, even it look like a hole in 2D, it might not be a hole in 3D because it's kind of big interconnected. Okay, maybe one last thing. Border queue, you will see this function. Sorry. Border queue work with the principle that any of the label image that touch the border, the bounding box, they will be removed. Some of you have this object here. Anything that are touching the bounding box, the border will be removed. The same with the bigger picture here. You can see a lot of at the border will be removed using the border queue. It's quite useful for some certain application. And maybe last one before we jump into the software right now. So we have the threshold or top hat thresholding. Usually when you work with very thin features, that when we apply normal thresholding and you don't see any result because of the similar intensity, maybe the best way to work on a top hat. Okay, let's go to the software a bit better. Okay, now. So similar to what we see in PerGeos, is we have now dark interface, and then we organize in different tabs, as you can see here from the top left. Start page, project workroom, and segmentation, and you can see that now we porting this core profile as a workroom in Avizo and the reporting. So if you click quickly, you have this kind of familiar PerGeos interface in Avizo. So everything will be done here, and you can work together with Avizo project workroom. So to start with, you can see that when you at the start page of Avizo, we have this way to open data. On the left, we send data, so you can see that I already worked on different kind of data before. You can open new data set by click open, or you can open a project. And good news, because I got some questions that if people already work on PerGeos project, what gonna do with the new Avizo features, so you can work or open all the PerGeos in new Avizo, so no problem. Even you already create a lot of project or file that you are working with PerGeos, this will be supported in Avizo. So, no problem at all. So first thing, let's load the data set that we can use it for tutorial. We're gonna work mostly first in the project workroom, so the second tab here. Okay, you click on the project workroom, and this is the main workroom that we're going to create any kind of workflow and 3D viewer. By default, you have project view on the top left and property port on the bottom left, and on the right here we have 3D viewer. Just worth mentioning to get the, because it's still beta version, but later we will have this data embedded in Avizo software. But now, right now, we need to do the extra installation. So if you click on extra, you don't see it here, but in my screen we have extra installer. So So just click on extra and then extra installer. You choose sorry, internet connection. Yeah. And I think the internet connection is gone. That's why it's in the. Can you check? But it seems like the screen here also off for some reason. Okay. Try one more time. So if I go to extra and then you choose the option extra installer. I just connected.
Yeah.
Okay.
Yeah.
Okay. Once I
Also
I'm gonna do this. So once you click on the extras installer, you see this screen. Okay. So this is extra page. You can also access them directly. Use extra.amira.avizo.com. I can send you the link later how to. But usually it's embedded in Avizo, so you can just go to the tab on the top. You can see extra, and then when you click on extras installer option, you will see this list of digital rock data. Here we're gonna use this data for this demonstration. For this. Yeah, so click on it, and you can see that usually really convenient. You can just click to install about 400 megabytes. So click install, and when you install, you can get all the data into your Avizo folder. That takes a while. Is anyone that have Avizo can see this option? Is there any question? Just please don't hesitate to ask me. It's gonna take a little while to install. While I'm at it here, you can go back to this extra folder. Actually, you can see that they have different type of extra. So it's kind of add-on plugins. You can choose to install and work on it. For example, if you want to do deep learning, and you can see some kind of tutorial that you can search and you install directly into your Avizo. So for example, if you want to do the hash extraction, or you want to start to train the neural network, or even denoising, you can do a lot of tutorial here. And you can see now that my installation is complete from the previous digital log. Okay. I'll go back to the digital log quickly. And if you click one more time, you see that when you complete, you have this option to open the folder. And the folder that look like this picture. So you have all the data. Okay. So what you could do, you see that it by default it's on this digital rock data. You can drag and drop this to Avizo. Yeah. Or you can just go to Avizo and open this from the folder that you installed. It should be in the Avizo folder. So I switch back to Avizo quickly. Avizo. So now after installation, now I open the data. So you can also click open data over here on the top left. Click open, or you go to file and open data add. But yeah, as you can see that I don't see any drop down menu. So just click open data over here. Yeah, open data. And one more time, when you have open data, usually it will point to the root here that the version you installed 2024.2 beta 1, and that's where I try to find the folder. Just So still cannot figure it out actually where they install this. Yeah, exactly. Sorry for this because I thought it would be easier to find, but when they finish the release, the new version, you should be able to find. So you just again go to extra, and you can select to open extra folder. Once you click on extra installer and select to open folder, you should see this folder here. And you can see that I have two extra installed in this folder. So it's on the digital rock data. And then select maybe first try with the image Pore subplot. Yeah. So we're gonna start with this one. It's worth mentioning that here you see that they have the Pore subplot review.am. AM is just Amira Avizo file. Okay, just to explain a bit, when we start the software, we have a software called Amira software, and later we develop Avizo software. Now both are the same functionality, but just different name for different market purpose. So mostly Amira software for life side and Avizo software for material side. So by default, they have everything on the Amira format. So that's why it's called .am. And you can see the second image is .labels. So usually the AM is just normal, original grayscale. After you work on the data, you can extract the label image. I can explain to you later when you open it. So now we just open this one, the Pore subplot view.am. So just double click on it. You open directly. Sorry. That's strange. Is it open on your Avizo right away? Because I think if you have only one Avizo, it will open. But for me, I can just drag and drop to Avizo. Easiest way. And now, so you can see like this. I can go in here. Exactly. Just the easiest way, just open that folder and then drag and drop into your Avizo 2022 24.2. Yeah. Because sometimes it by default they open the Amira PerGeos Avizo. It's okay. Okay. Just here. Just yeah. Any. Okay. Yeah. Okay. So yeah. Usually you can just drop to the software anywhere and then it will open it. Any question? Is it possible you can solve them? Okay. So let's explain a bit more on the interface of Avizo software to understand better. As I mentioned on the project view, it's here where you go in to do anything, image processing, segmentation. So you can do everything here on the project view. Under the project view, we have the property part. So it's showing, for example, now on the highlight auto slide. So if you click on the Pore subplot itself, you can see that it shows all the property parts. The grayscale 16-bit, the intensity values from 9000, 9544 to 2561. So this is range of intensity in each pixels. And if you look closely, when I click on the Pore subplot, it turns from empty green to solid green. And the same for auto slide. If you don't click on it and then you click on it, and you see it becomes solid and empty. The color code here telling you what type of module that we are working on. So if you see orange, that's indicating this is 2D visualization. And later when we do 3D visualization by attaching new module, you will see that it turns to orange or to yellow. And if you click on the dataset, the normal data, original grayscale, it becomes green or even label image green. And then if you apply some computer, it's gonna be red because it's computing module. So everything you click on it, you will see information. And let's first quickly go to auto slide just to explain. So in auto slide, you have the properties for on the bottom. And here you can do, for example, change orientation of your slide from X, Z, X, Y, and Y, Z. You can see change it. And when you are on whatever orientation like X, Y, you can change the slide, go through the data more interactively. And then come to this color map. It's very important to understand because you can see this, the histogram and the range. It starts from 59544 and 2561. So does it mean is min and max value of intensity, but you can also adjust them accordingly. So as you can see the histogram here, if you reduce the maximum intensity, that means any pixel that have values up to 1.3 or this value 13,000 will become maximum. It becomes saturated, or even you can adjust more. You can see it's kind of you clip or cap the upper intensity. The same for the minimum. So if you change from 9544 to 10,000 like this, is it more prominent? That any pixel intensity less than 11309 will be turned into 0 or completely black. And this way, when you work on this intensity, you can see the contrast dynamic range of the object. And then just look on the data set quickly. So it's grayscale 16-bit, and you have window. So this window meaning that any intensity below 9676 will be considered as background. And then, so you can see the distribution of the window is max to 12462 because the other intensity we cannot capture in this thumbnail over here. So now the way to attach module to this data set by you click on the data first and then right click on it. Once you right click on this data, unfortunately you don't see the drop down menu. I try to see if we have them here. Okay. If you right click, you will see drop down menu. On the drop down menu, you can see on the left we have two sections. So the top section is just like favorite, recent, and some different folder, but consider the lower section of the folder. You can look on any folder. For example, you look on the display folder. If you click on display folder, on the right of the display folder, you can see list of modules that can be attached to this type of data. So different data, they will show different type of module that are available. So you can, because some modules only take only the grayscale, and some modules take only the label image. So just keep in mind that to select the module, it depends on the data. Maybe you don't see everything available for this type of image. So again, right click, you should see a list of module, or the easiest one that you can just right click, and in the search box you can see that enter a search string. So if you type, for example, volume rendering, if you type volume rendering, yeah. So I just can double click or create the volume rendering like this. And now you see that the volume rendering has appeared here. And it becomes yellow. So this is 3D rendering. Again, you can adjust rendering quality of the image by adjust the color map on the bottom. You can see that there are two tabs, volume rendering, top and bottom, and the bottom one you can adjust again the color map dynamic range to set the maximum saturated or the minimum value. As you can see, when I start to play around with minimum dynamic range, that means any intensity in the voxel, 3D voxel, less than this value will be take as a background, so it becomes transparent, more transparent. That's why you see more of the porosity inside, based on the cutoff value that you would like to work on, the minimum or maximum intensity value. And you can make also more porosity, more opacity, or more transparency as well. Yeah. Okay. This is a visualization in Avizo. And all of the visualization you can change. Let's say, for example, if you go back to auto slice, one of the principles in Avizo is that we have different connection port and visibility port. So let's take a look at the visibility port here. You can see that in all of the modules, you have two boxes. So the first one on the left is the connection port. As you can see, this connection port, it can be connected to any data if you look on the auto slide quickly. So this connection port actually is this one that you can see here. You click the drop down menu, you can see no source, that you have no connection, or the body as a plug. This is exactly the first little white box here. So if you click the same thing, you click on the little white box of the port, you can see that they have possibility to connect to this data. And next to the little white box, so is the blue box, is the visibility. So you can switch on and off either directly on the module. If you click, you can see here the auto slide, or to volume rendering, it's turned on and off. The same, you can also toggle on the property of the volume slide, the volume rendering or auto slide. For example, if I click on and off, same thing, on and off. This is the visibility. And for example, if you want to completely shut off the visibility of the whole data, then everything is different. And the reason we have this visibility, because sometimes you open different data sets, 2 or 3 of them in the same time, and you just want to see one project or one group of data. So you might need to turn off one of the data you don't want to see at the moment to avoid confusion, because so many visibility or rendering here. And one of the things that you might come across, that you don't see any information of this data, or you lose somehow. For example, you can change the docking for property port somewhere here to the side like this, or you can just make it over here, or you can completely close it. As you can see, that there are different ways of chain layout, and sometimes you instantly close them like this. So to get back to the default view, go to Window, and in Window, at the last option, they have this Restore Default Layout, and you click, you will get back to the normal 3 windows layout. Again, if you close some of the windows, you can go to Window and try to select individual property you want to see, or just click at the last option, Restore Default Layout, then you will get back to the normal window. I think it's quite important to understand. And last thing on Avizo project to really important for you to understand as well is the tool here on the top right. So to start from the first one, we have this tool, the arrow and the hand tool. So these two are interact tool and the hand tool. So what the difference between the hand and interact is that, for example, if you are a hand tool, you can just use to rotate object around. But if you would like to start interact with, for example, now I would like to look only on the auto slide, so I go to volume rendering and turn off quickly. Now I have only auto slide. You can still turn the auto slide around using this hand tool on the top here. But if you change from hand tool or trackball tool to interact tool here, now you can see you can directly interact with this object. So, and it's really useful because later if you would like to do some image registration, you have 2 images, 2 volume, and you would like to bring them together. So you might need to start change between rotate them. For example, I go the volume rendering, you might want to rotate them and later use this interact tool to move them around. That's why we need to get used to changing between the hand trackball tool and the arrow, the interact tool. When we can see that when you hover the mouse over of this tool, there we have the shortcut. So for example here, the shortcut is escape key to change between these two. So if you click escape, you can see that the change between arrow and trackball tool easily. And then we have this translate tool here. the third one, the translate. So the translate, if you click on it, then you can just translate. Or you can just use the middle view of the mouse. So if you use middle view of the, if you on the hand tool, and then just click on the middle view, the mouse view, click and then hold it, and you can just translate it quickly. Okay. Usually, if you don't hold the middle mouse view, then you can just turn them around. But if you just click and hold the middle mouse view, then you can translate them. The same for zoom, the magnification. So you can just use the mouse view with left click. So left click and mouse view to zoom in, zoom out together. Left click, mouse view, zoom in, zoom out. It's very fast. That's why it's really important to use mouse for Avizo. Yeah, zoom in, zoom out. And then we have this step rotation like this, rotate by step. And then we have the zoom, the seek. You can see the icon here. If you click on seek, and the seek will appear. So if I want to zoom in at this region, at this point, so you can click. You start to see that they will zoom in at that point and recenter them. And again, if I do one more time, seek over here, somewhere here. If you click, they will zoom in and then recenter the object to where you seek. And this also could be useful if you want to create some nice animation like studies too. And then we have home and set home. I think that's clear because if you just do something, you can just click. Suppose I translated here and you click home, they will come to the home position. And then we have this camera view. Just we turn off volume rendering using this tab here on the project view. And you can see I have already auto slide. So the camera projection here is X, Y, X, Z, Y, Z. That's actually what you see is that the image, let's say the object we work here, it doesn't move. What moves is that how we project your camera into the object. For example, you have the object like this, and you look on the sides, on the front, on the top. So this is how you hold your camera. So this is a tool that it act as if you point your camera to this image. Yeah, that's why when you click, and you can see that. And important one is the view all. So the first one, for example, if you zoom in very, very large, and you might lose sight of your object because you zoom in, you can click this view all, the first one. Yeah, it will come back to the fit view. The same also if you translate or move it aside here, and then you can just click or press space bar, it will come back to the view. Yeah, so the rest is more not much important at the moment, but I will come back later if you have any question. And then you can look at the two viewer, four viewer as well. So we just stay on one viewer. So this is pretty much about Avizo. So just get used to the principle that to attach any module to this data, you have to do right click. And in right click, you should see a lot of drop down menu organized in the folder or in a favorite list or in the search string. So you can do many things. And one thing is also really practical in Avizo, and for people who doesn't use Avizo before might get confused because in PerGeos it's more linear workflow. You just work step by step, but in Avizo, everything is visual programming. So we have the data. Let's say I will do like this segment more. So when you load the data, you don't see anything because we just load it. The data is there, but to be able to visualize them, you need to attach visualization module. To visualize this data, you just need to think what type of visualization you would like to do. So the easiest way, you can just right click on the data and go to on the left, select display folder, and you can see list of visualization module that can be attached to this type of data. For example, if you select to attach the bounding box, or you can just type bounding box, and you can see the bounding box coming up. Again, I give you a few examples so you can get familiar. And then if you right click again, go to display folder and look for auto slice. Double click on auto slide, and auto slide coming up. And then finally right click one more time and search on the display folder, look for volume rendering, and double click on the volume rendering. So now I have three visualization module attached to this data. And you can see that the way they attach, it look like this. So each of the visualization module, like they always have this data port. You can see in the property here, this data port. This data is just string that you see here. So I can pull the string. Or if you just left click and pull string, then now I disconnect the module from the dataset. Again, if I go to bounding box, I pull the string and I release it, and pull and release it, something like this. So it's gone, disconnected. This can be done the same way if you would like to connect them again. So you can go to little white box here, and when you click on the little white box, you can see that they have the data. It's the same like here. If you click on the data, on the drop-down menu, you can see list of available data to be attached to. So you can just select here to connect, or you can just click on the little white box and select data, and you get the string attached to it. So either way, choose. So if you have, if you choose to select from the data here on the property port and select from the drop-down menu, if you have only 1 or 2 data sets open, it will be okay. You can find it easily. But if you have maybe 10 data sets and different type of module, maybe the easiest one just to click on the little white box here. You can see like bounding box, click on the first white box and then select data. You will have string and then put string to attach them. Again, to volume rendering, select data, attach them. Like okay. And another easiest one to attach any module to the dataset. For example, you click on the body subplug, you can see list of the previous used module that are available here. So you can select again the second bounding box, click, and again auto slide. As you can see here, we can attach many auto slides, many bounding box, but it's only allowed to have one 3D volume rendering. So you will not be able to search for the new volume rendering on the body subplug. If you go back to body subplug, like click and look for display, and you try to find volume rendering, it's not available anymore because it's already attached. Even you try to search for volume rendering on the search string, you can see that they're not coming up because it's only allowed for one volume rendering. Okay, just keep in mind, volume rendering is only one, but bounding box or to the auto slide, you can attach as many as you need. Okay. So now let's look at some image preprocessing to start working on this data. So first thing we need to do, I'm gonna show you. So you go to right click of this data, and on the search string on the top right, you see the enter a search string. You can type filter sandbox. Okay, I type and then I show you quickly when you attach. So when you type and click, double click or enter, you attach the module called filter sandbox. Okay. Again, you can also pull string to unattach, or again, click on the white box and then select data and attach that. So the filter sandbox come with on the right here with the hand tool I have filter sandbox with the preview of the sandbox here. So if you would like to change the location or the size of this blue sandbox, you have to change from hand tool to arrow tool first. For example, here, arrow, and move them around here, like this. And look at the properties of filter sandbox, and you can see that the color map showing here. You can change dynamic range of the filter sandbox to see easier. Or you can easily adjust the color map to the preset. So if you click on this edit, you can see again drop down menu. On the drop down menu on the edit, you can select the first one, adjust range to, and then you can select adjust range to data histogram, and you can see more automatic adjustment. And you can also manually adjust it, of course. And one thing you can do as well, you can also change the color map of this dynamic range. For example, if you click on edit And you can see on the bottom row, they have lists of color map you can change to. If I change this color map to physics, you can see something like this. And adjust again dynamic range. You can choose any color map you wish to adjust dynamic range. But for filter, I think it doesn't matter which color you use, and then it should be it makes more sense to use grayscale and then adjust a bit dynamic range. Now I will show you what this filter sandbox do to the data. So we're gonna do is image pre-processing. If you're familiar with PerGeos, you remember that first thing you need to do, you need to click on the image processing workroom, the next tab, but you don't have to do that right now because we're gonna do it right here on the Avizo workroom. So what we're gonna do now, we zoom in a little bit. So I use left click and middle mouse view in the middle just to zoom in quickly. Just to show you that if you zoom in very close, you can see that it's quite pixelated. This noise we call salt and pepper noise because it's really contrast between, you see inside of the, let's say, rock here, they have gray and black and white, so salt and pepper, that's the name for this noise. So we're gonna apply some filter and to see what it happened to this data. And if you remember from my previous presentation, just quickly. Okay, then just quickly back again. If you remember this slide, we're gonna apply different filter, and if you want to do median filter, that means like in each of center of the pixel. So you do 3 by 3 matrix, and then you just move from one until you finish all these images. So now go back to Avizo one more time. If you have any question, please stop me and ask me, okay? I know sometimes it goes very fast. So to apply any filter, at the bottom of the filter sandbox, here you can click on a drop-down menu and you can see a list of filter available. So you have bilateral, you can change to box filter. And you can see when I apply box filter, it's kind of apply the blur effect, the mask. And you can see even further. So this is, you can see the preview before and after the filter. That's why I tend to work on median filter for this type of noise. And you can see when you apply median filter, that the noise has been removed and you can still keep a lot of structures and you can even see the porosity. And you can also see that you can change number of iterations. So if you want to increase more blurriness, you can just type maybe 5. You can see the more you put the iteration, the blur increase. And here the most important, the interpretation, that you want to interpret them in 3D or 2D. Some certain cases it's no different at all because the interpretation it doesn't give much difference, but some data might. For example, you see now if I interpret in 3D, that means they will take more depth into account as well. So they not only consider the 2D pixels surrounding in 8 pixels, but if you select 3D, you have option to select neighborhood of minimum 6, 18, and 26. So it depends on how much the neighboring voxel to take into account in 3D. And you can see that in 18 it's still quite okay. Maybe 26 is a bit too much. Or even this type of data, maybe only 2D interpretation also makes sense. And you can try also, for example, if I do different type of filter, if I do, let's say, delineate, maybe, not sure. It might be useful for some certain cases. Or you can do unsharp masking. You can also combine different filters. So first you apply one filter and then you reapply them again. So the most recommendation is that you go to first using non-local means filter. You can see that this non-local means filter are really computing demanding because we need the CUDA adaptive GPU manifold. And then after you apply the local mean filter, then you can again reapply, for example, unsharp masking and to increase contrast and also exercise to enhance. So, but just the preview, so you can see the preview. And I'm not gonna apply unsharp masking here or not null for means filter because it's gonna take so much time to calculate a lot of GPU computing. So we can apply quickly in filter using iteration of 3. I think this is the default value. Click apply. Now it's done, you will get the new data set coming up. If you look at the computing module, now it's in red because it's computing. As you can see here, we have option to do the apply, the effect. So if you click on maybe change iteration from 3 to 5, and you have to click apply again to get the new results. If you have powerful computer, you can also click to do auto refresh. When you click auto refresh here at the bottom, the apply button will be fade out. That means everything you change, it will be changed on the fly. So, but if you have computer like laptop, don't do this because it's gonna take so much computing on your GPU and CPU. So just so you know, later if you were on workstation, you can maybe do auto refresh to see the result on the fly. So now I go back to 3 and click apply again. And now when I have 2 data, you can see that the first data set and the future one. And later, if you have really long name, I know that some of your image, usually the file name is come with like condition name data, so on. It's gonna get longer and longer and longer, and you cannot find anymore. Because if you look on the modules that you attach, like Visual Sandbox here, if you look on the data port, you click on the drop-down menu, you will see a list of the available grayscale input. Imagine if you have a really long name, it will be impossible to find it because it's too complicated. So what we can do, we can change the name or rename them. You can rename everything using F2. Press F2. So F2 here, and you can see, let's say I change this to just what is a plug again, and let's say I change this one F2 and then go to just only the filter. You can even say that I do median filter, so you know this one is, if you want to compare different type of filter, median filter, like this. So this now maybe it's easier for you to find the folder or understand better what you're looking at. Yeah. So now I'm gonna start compare these 2 data side by side. So you go to first double subplot functional data, and then you can right click. And on the right, you can see that they have list of auto slide, or you can type auto slide, or you can just select auto slide from the top here, project view. And now you see that you don't see anything because the Visual Sandbox is still opening. You have to turn off or delete them. You can easily toggle the viewer off by click on there, or over here at the property port, a bit bigger, so you click on them. So now it's gone like this. So it depends on would you like to see or to turn off on. Or you can completely delete them. So you can drag them to the trash bin to delete, or you can just click and press delete button on the keyboard, or you can just do it like this, select them and press delete, then the module will be deleted. Okay. And now I attach the second data, the result, the filter with auto slice. Again, you need to understand that if you click on an object with the 2 data, you will see like this. And that's why we have this multi-viewer. So if I click on the 2 viewer and then press spacebar for each viewer like this, then we adjust the dynamic range at the same value, say to 12,000. Yeah, 12,000. Well, and this one also go to 12,000. Value of intensity. And then if you zoom in here, you can see that on the right is the zoom data. To be able to see that, you need to look at when you activate 2 viewer. Now the viewer toggles of the auto slide also split into 2, so you have to make sure you activate one of them. For example, if I have to I want to show the original data on the left window, so I turn off the viewer on the right because now it's split into two. The same for auto slide 2. Now I turn off the visibility viewer on the left. Then I have this viewer setting like this. What you can do, you click on one of the auto slide. For example, I on the viewer. So if on the left viewer, right click, and then select link camera to. Right click on the viewer here. Sorry, you cannot see it. Right click on the left viewer, and when you click, you can see the option, and then in the middle there's something link camera to link camera. Right click and select link camera to, and you can see that camera icon tab here. You move to the right viewer and click on it. So now it's been linked. You can see this side by side. Okay, it's just to compare the. Because now the way I link camera, so you can see exactly. Okay. Is any question at this point? You would like me to repeat? Okay. And now, just go back to one viewer, and we're gonna work on segmentation. If you remember from PerGeos, so first you go to tab step by step. The first tab, the first workroom is image preprocessing. The next one is segmentation. So in Avizo, what we do, we just directly attach the segmentation module like auto thresholding, interactive thresholding, or any kind of thresholding. So let's go to the first data set, the barrier subplot, whatever. Right click, and then let's say you can go to compute folder. On the left, they have folder. It's a folder of compute. And in compute, you can see that they have, sorry, I was a bit lost as well. It's not, let me quickly. No, it's not compute, sorry, it's on image processing folder. So again, right click on the first data, right click and locate the folder called image processing. And in image processing, you should see smoothing and denoising. Okay, let me check quickly. Okay. Because I get used to type for the search. Okay. Okay, one more time, just repeat. Sorry for this confusion. First, right click on this, and then instead of image processing, is the next one is image segmentation. Sorry. So the folder image segmentation, and look at the image segmentation on the right. The first one, binarization, and in binarization you can see list of threshold that you can use to work on it. So let's go with interactive thresholding. So for the first few times, try to locate this whatever module inside the folder, so you can get the feeling what type of filter you can use or what type of module you can attach to. That later when you get familiar with it, you can just type on the search string. For example, you want to do interactive thresholding, you can just type interactive thresholding. Now I have interactive thresholding attached to the data. And when you look at the property part of interactive thresholding, you can see that they have this important on the bottom here, intensity range. So this is where you're gonna adjust the mask to select only the pixel or voxel that have the intensity of needed, because now they have range of minimum to maximum intensity. So now I would like to threshold not the porosity, so you can move the value from the lower value to 11,000 to, but you can just see by look on the right 2D viewer here. So now I can see that I adjust the lower intensity to 11,000 to 130 like this. You can see on the right coming up the blue mask. So this is a preview of what you see before. If I just move this completely like this, the threshold to really high, you don't see anything because it's just only the grayscale, and I just dynamic range on the top again. So original data is grayscale, but when you apply the mask based on your intensity, this blue mask will turn into so-called a label or binary image. Why binary? Because as you can see here, they only have two values, 0 background or 1 as a blue mask. So that's why we call binary. But later we call them label image because it can be multi-material. So let's say if you adjust this intensity to, let's say, 12,500, you can see 11,000, and then let's go to this value 11,230. As you can see here, what I want to show you is that I attached interactive filtering to original data. You can see this kind of porosity before the filter. But when you change the data, let's go from, you go to the data port here and select from drop down menu and select the median filter. Now you can see that it's much smoother because of the filter effect. And instead of trying to change on the data from the drop down menu, you can also try to pull string from the original data like this. And then go to the view. Let's try to get familiar with this. It might be a bit difficult at the beginning, but later when you get used to this principle, you will see it really flexible because you can apparently track where you are and where you want to work with. And you can see here that why we need image preprocessing, because before any filter is very noisy. Even if I would like to adjust the intensity just for the porosity as well. Here you can see that much of the noise at the same value, and you pull string toward new data, so you get pretty much remove most of the noise. So it depends on type of filter that you apply. Is it okay so far? Yeah. So let's say now look at the data that already filtered, so median filtered data, and with interactive thresholding, you can see that by default we have preview 2D, but you can also check to see the preview in 3D as well. Click 3D preview, and you can now adjust the dynamic range to whatever you like to segment. Let's say I would like to segment the solid part, not the void, not the porosity. Or you can segment the porosity as well. I think when you see this segmentation and image processing in 3D, I think you will never go back to PerGeos again. In terms of 3D visualization of the preview, yeah, like here you can see that you can already see directly the preview what it looks like. So when you turn off, turn on 2D and 3D. You can adjust any value you wish, like here. Yeah. And then click apply. So you get a new data. And then if you look at the property part of the data before and after the interactive thresholding, now you can turn off the interactive thresholding. The visibility here. Okay. So when you click to toggle off, it becomes gray, but it is blue. You can see it's not. So quickly look at the data. You can see that before we apply the interactive thresholding, it's still grayscale, 16 bit, and then you can see the value is a lot, like thousands of values of intensity. But then if you go to the result from interactive thresholding, now it becomes a binary image. And then you can see the two values, 0 and 1. That's why we call it binary, because it either, you can see from the thumbnail that it's either background 0 or it's blue as 1. So 0 and 1 binary image. And we call it as a label image. At this point, our label have one material. So everything in blue color map is just one material only. So we extract the mask, and the mask considered as one blue material. So now we want to separate them into different materials. But before that, we can just quickly take a look by attach the volume rendering. Again, right click and type volume rendering, or just select from the drop down menu. Just click. You can see this original grayscale up there, the filter. If you pull the string to visualize the data, now you can see this is our label image or binary image of segmented rock. Sorry. So what I'm going to do more here, I want to separate them into individual grain. So it will use some algorithm for vertical segmentation to split at the thin point. So right click on the thresholded data and type separate object. So in separate objects, the most important thing is the marker extent. So this marker extent telling you is the H maximum. So it means that you would like how much you want to separate them from each other, how much you want to split. Let's say if you have the lowest marker extent of 1, you will have them split as much as possible. And if you increase the value to higher, maybe you will have less objects separated. Okay, and you can see that they have different type of output, but for the time being I will show you that output type, instead of split, you can select at the last one, connected object, the last option. Yeah, you see that I select the output type as connected object and click apply. Yes, the market I will show you on the next preview. The market extent, it just tell you how much you want to split them from each other. If you have lower market extent, the more object will be split. That means the find more thinning point. I will show you on the example. You will see very clearly why. Here now I look at the thumbnail just to show you quickly. So if you look from the beginning, you see the thumbnail is grayscale. It shows thumbnail in grayscale, and when you do the thresholding first, it becomes a label image binary because it's 0 and 1. The thumbnail is only blue, one materials. And then after you separate them, now you look at thumbnail here, they have more color, and now you can see that they have information. It's not the binary image anymore because it's not 0 and 1, but it's 0 to 176. That means they separated into 176 pieces. So that's why we don't call it that binary, but we call label image because it's multi-material. And the material numbers, the ID, is just randomly assigned based on the color map on the below here. You can see that we have the 8 color map. So from light blue, dark blue, red, and so on. And now you can also pull the volume rendering to the separate objects. Now you can see the object has been separated based on these markers. You can see because I use marker extent of 7, you have like larger chunk because less separation. But if I change back from markers from 7 to 1, you will see that it completely changed the way of they separating using the algorithm. Okay, and to even understand better on the option of this separate object, so you can also quickly turn off the volume rendering, or you can just delete them, that we can attach them later, no problem. So let's go to separate object result here, attach auto slice, maybe in XY. Yeah, so with the output connected object, if you do 1 and then marker extent, you can see a lot of object has been separated based on the thinning point. And then if you increase from 1 to, let's say, 9, you will see that they have less separated. Just to explain, like this. And now let's look at the different options. Let's say go to marker extent of 3, just optimum marker extent of 3, and then the output types. First one, split. Click apply. With the split output, you can see that they just show object has been split. but they don't have individual objects. They just split off each other, but they still call this as a label image. You can see when I click on the result here at thumbnail, and still showing a binary because even they're separated, but it doesn't show as a multi-materials. That's a split. So the split based on the marker extent. And then from split, the second one is line. This one showing the watershed line because the watershed separation is made with the watershed segmentation algorithm. So select the second output type, line, click apply. Now you see that this is the watershed line that's been created. Yeah. It depends on the object because separate object mostly designed for round object. Yeah. Mm-hmm. Yeah. Yeah. Exactly. Exactly. Yeah. Yeah. Exactly. But then I can show you later as well, or maybe on one that now we have more powerful feature to easily select object to be edited, like between two object merge and so on. Yeah, but still you need to manually edit them. Yeah. I can come back to like. Yeah. And then click apply.
When is this?
Just to show exactly where it's from. We never use time. Or you can.
For what, like analysis?
I never use it. Just for demonstrate. I mean, just to show you what it where they calculate. But you will see it clearly. You will see it clearly why we need this. Okay, to understand even better, just pull the auto slice and attach to the filter data, the grayscale one, like this. And when you use the auto slide on the different filter, different data set, you have to set again the color map. Let's say you visualize the median filter data with auto slide and adjust the dynamic range a bit like this. And at auto slice, right click on it on the auto slice, right click. You choose the option on the second line, color watch. Okay, right click at auto slice, and a drop down menu, select color watch on, I think the second one on the this color watch like this, and create. Now you see the color watch module attached to auto slice. Yeah, I'll come back. I'll come to you for sure. Yeah. Yeah, in reset, you have to adjust the color map dynamic range over here. So every time, I know it is annoying, we need to work on it because every time you switch from one data to another data, the color map dynamic range change. It kind of reset back, so you need to adjust the dynamic range here to see it clearly. So for example, if you have this, edit and select, adjust range to data histogram, you have this kind of visualization. I do one more time. So it is not good, you can completely delete it and then attach the new auto slide, and you could get a better view. Right click, okay, it's not, adjust the dynamic range here. So what I want to show you here, right click on auto slice, and you should see on the right drop down menu, you just select color watch, double click on it, and this color watch should attach to auto slice. And what we're going to do now, we would like to overlay the separate object data here on top of the grayscale data here. To do that, you need just to go to color watch. In color watch, if you see there are white box as well, click on it. You can see the data. Here we're gonna create a link data to this here. Or you can just go to color watch at the property port and select the last one, the median filter separate, like here. I come by. So I just want to show you quickly here that in separate object we have different modules. So I show you that just use other slide, overlay with color watch, and then look at different results. If you look at the split options, you can see this the overlay of the object has been split. You can see here based on the marker extent. If you have like one, will be split more, but still consider as one materials, but split more. But if you go to line, this is you can see that the split based object is based on this slide that you created from watershed segmentation algorithm. And then they have now the basin that we call watershed segmentation basin. So you can see how the basin are defined onto the objects. And you can see here, you can also adjust the transparency in color watch. So go to color watch. And the transparency, you can see that you can adjust even more transparency. You can see exactly where the basin had been created. And actually they have two basin and basin 2. So this first basin, you can still see the gap of watershed line. But basin 2, you will not see the gap anymore. It becomes like this. As you see here. So that means this kind of extend the basin. And finally, can see the last option is just the mask of this basin into the binary image that's called connected objects. So this is the last option that I like it the most. So actually this last option is the same like the first option, but for the first option, if you just do the first option split only, you get the same result. But what you need to do, you need to label them. For example, if I have them split like this, as you can see, now you have to right click and then labeling, and it is the same way like you did before, that you just label them into the individual color. So this object has been separated. Yeah. And I will explain this in more detail, or if we don't have time, we can also, I can send you the slide about watershed segmentation. Yeah. Yeah. But it's the same, like what other same? It's the same engine. Yeah. So, and when you come to this point, you can already see that first you have binary image 0 and 1. Even you separate them with the split, you have 0 and 1. And when you label them, you see that you have 7, 5, 9 objects. And I think the most important thing now, you want to get the information out. So right click and type label analysis, or you can just look on the module, the folder called measure and analyze, and look at the individual measures. So measure and analyze individual measure and select label analysis. Like this. So this label analysis is really, really important. So take a look at the measure at the bottom. So we have basic measurement. If you want to know what its basic measurement contains, you have to click on the 3 dots over here. So once I click on the 3 dots, so I should see this list of the measure group like here. So you can see that by default it's on the basic measurement, and the basic measurement, you can see this list cannot be modified, and they contain volume 3D, area 3D, valley center of X, Y, and Z, and mean intensity. You can change to, let's say, standard shape analysis. But if you like to create a new measure, it's easy. You can click on this button here, and again you have to name them. Let's say I name the new group as KAUST So the first option here, you can see, yeah, to create a new measure group, and I name them as a measure KAUST. And now you start to define your list of measurement. Let's say go to geometry, and in geometry you can see list of many things you would like to add. Let's say area 3D, area fraction, orientation or perimeter, and you can look at the sphericity or symmetry and so on. You can look at intensity as well, gray mass, intensity count, anything, median filter. You can even create your own measure. Let's say I want to create area fraction. You can click on this plus, you see custom measure. No, mouse. As custom measure on the top left, then you can click on the plus sign, and then you just, let's say I want to do area fraction. So this way you can kind of create or modify your measure. Where is it? It doesn't show up here, unfortunately. Yeah, it doesn't. I want to show the list of measurement, but yeah, I can show you individually. Anyway, I just want to create the new measure, but I will show you because it doesn't come up here. Anyway, so while you have the custom measure of the measurement, here I use this custom measure, the KAUST that I just created, and you click apply, and now you get these new results here that show on the table over here. So we can continue. Now we're gonna focus on the core profile. So what we can do here, we're gonna open the dataset. Again, you can go to the extras and select to open extra folder. So it should be on the digital rock folder, this one. And just select to open this one, the core sample CT. This one, okay? Just maybe drag and drop to Avizo. The core sample CT 7494 and open, and then go back to Avizo. So usually when you open, they will ask about the unit. Yeah, you can just select any unit, and voxel size you can change them later. Yeah. And one thing we could do before any image processing, you can change the unit. You can see on the right here that I have my mouse, they have the unit. So I want to change, let's say, to millimeter, micro. Okay. Yeah. So anything calculation is based on this unit. So make sure that you change the right unit. You can go to edit, and then drop down menu, and you can see the second from the last, preferences. And you should see this screen, and then let me, yeah, and then go to units, and then just make sure it's on. Yeah, because it's off, then it's not showing, but you can activate on and off the unit. Is okay? And then we click OK. Oop. Oh, because I turned it off. Yes, and now I come back to Avizo, and then you should have the unit over here. You can see, and then you can just select unit you would like to work with. Yeah. Yeah. Yeah, because if you change unit, you have to recalculate everything. Yeah. 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 Exactly. Yeah, exactly. If you, yeah, exactly. The first thing, just make sure about the unit. So yeah, the first thing. Yeah. And also you can also change the worker size here as well if you would like to do. So just click on this here, the crop editor. And when you select crop editor, you should see, no, strange. I don't see the box. Anyway, you should see that there was a voxel size in the resolution, and you can change the voxel size if it's not correct, but I just use it as this. Okay, so now if you can see from the thumbnail, this is core, and then usually the core is not the way you scan with the CT is not very straight, and then you need to align them based on the axis. As you can see from the thumbnail here. So let's go to, let's quickly on the volume rendering. Yes. Just stitch them. Yeah, exactly. If you have like a few sections together, you stitch them, and then the alignment is really easy because now we port the crop core to here, so you can see this. So this is the core, and what you could do here, I can also introduce the, I think it's not unofficial, I'm not sure, clipping plate. Yeah, but different type of clipping. So you can attach clipping and change the clipping direction. So right click and type clipping plane, and you should get the clipping. So for example, you can go to X, Y, Z, or any direction you want, and then click here on the property port of clipping plane to clip them. So now when you clip, you can see this 3D clipping, and you can always translate the clipping direction or change the clipping direction to clip that. You can also do with auto slide overlay, but here it's just only clipping. There, you can see that it just like cut through the object that to show you the another possibility. Yeah. 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 So I change the color, so it's still cut to the color volume. I changed because I want to show you that because it's not auto slice. Yeah. Okay. So now first thing we need to do after you stitch, for example, right click and type crop core. This is the first thing that we do with PerGeos. Crop core. So how you determine the diameter? So you can move this property port a little bit here. Okay. So to look at the core diameter, so I remove this 3D volume just to something fancy to show you. So attach the auto slice to this data set. Right click and select auto slice and select XY like here. You choose yes. Okay. Sure. First, open the data. Okay. First, open the data and nothing else. Okay. Remove everything. So you can like drag everything else and delete. So you have the data. Right click and select auto slice. So you can type or try to search or use the auto slice coming up. With auto slice attached, you will see this core like this. And the reason I show you this because we want to determine the core to be cropped, because usually as you see on the 3D volume, it's not maybe not well aligned with, like you see that there's some kind of tilting you see at this region here, so we need to crop them. So that's the module that we're going to use. Right click and select or type crop core. So this crop core is on the compute volume operation folder. Can you find it? Quickly. This is on the compute folder and volume operation. Yeah. Yeah, exactly. Yeah. So you can Can you right click one more time? Can you delete it? Yeah. And right click. And then you type crop. Yeah. And you double click on it. Yeah. When you can use it, you just remember some name of and to. So the first thing we need to determine the core diameter to be cropped. So usually we can just use this, you can see here, kind of measure tool over here. If you click on it, on the ruler here, and then you can just try to estimate the diameter of the core that you would like to crop. Yeah. So it's about 127 millimeter. Yeah. Yeah, 127. Because you want to just avoid the round outside, just to have a bit less. So I'll come back to the crop core and input this number 12700. So, but to be smaller. Yeah, because you want to crop them, so you don't want to get this kind of, yeah. And you can see that because they have maximum only 500 because of you have to go to these 3 dots here, and then you can see that min value and max value. So you can change to, what is this, like 500,000 maybe or 200,000. I think by default they just, I don't know, yeah, this is the kind of annoying. You have to click on the 3 dots here. When you click on the 3 dots, then you can change the maximum value from 500 to 200,000, for example. You can see that in the box, right? Yeah, you can input the new max value to 200,000 because you, yeah, because you see here it's 128, and then I want to input 127,000. Okay, because the way I determine the diameter just roughly is about 128,000 micrometer, and you see if you change from micrometers to millimeters, you can see it will change accordingly. Okay, it depends on what you prefer. Let's see would be, yeah, because now I change from micrometer to millimeters, the unit, and you can see that the line also change accordingly. So it's about 128 millimeter. So now the core diameter is changed to millimeter to 127. You can also go to the 3 dots and then change the max value, because now it becomes 200. So, okay. And then you can see that in the property ports of the crop core, so we already define the value of the maximum diameter of the core to be cropped, and we have the registration step that you can select to disable rotation, because sometimes it happens that when they try to register, instead of normal registration, but they try to rotate the core a bit. I'm not sure why it happened, but it sometimes it, yeah. So for some data set, you want to have exact position. You don't want them to rotate, but sometimes it rotates and we don't know. So if you want to make sure it will not be rotated, you can click on disable rotation. Yeah. No, that's the, for example, if you have the core that like it doesn't go vertical like this, maybe like this. So you want to crop and register them back to. Yeah, let's say if I have this like a core, right? So I have to select the maximum diameter, maybe just only in the middle, and then when you crop them, it's still tilt, and I want to turn from the tilt angle to more straight to the axis, coordinate axis. So this is registration. Just one moment, and when you register them, they have this option, the disable rotation, because sometimes you never know if they're gonna rotate from the local position. Yes. Yeah. Yeah. Exactly. But because usually like the core maybe when you scan with the CT, it's not usually that you have this like align with the principal exit. You have to sometimes tilt to avoid the artifact. That's what I know. Mostly they have to do like sometimes 45 angle degree in the tail of the rotation. Yeah, exactly. Yeah, yeah. Is need to check what is the do, because in registration on Avizo we have different type of the rigid transformation or shear or whatever, but I think it's only rigid transformation. Yeah, yeah. So for example, if I do this, show you quickly the option, but I'm not sure what is the engine here. If you want to do, yeah, you can see in, if I want to do normal registration with the module, you can see they have different transforms. You can do rigid transformation with the, I don't know, 6 degree of freedom or 5 degree, and then you have this isoscale, shear, and so on, translation. But I guess it's just only simple rigid transformation in this crop form. Yeah, yeah. Like you have the cylinder template of defined diameter, and you crop, and then you, yeah. Yeah. So now I just delete so this measure. You can just select and delete the measurement. Just done. Now with Croco, I just don't do visible rotation because I don't notice them. But just keep in mind, if you suspect that there might be some rotation when you do the cropping or because of the registration, you see this option. And the second value here, padding value. So you can just replace anything else to the background. For example, if you crop and then you can use the, if you go to this value, you can see that, you see where my mouse hover, right? And you can see at the bottom, the show value of 999 here, this value here. So this means it's the background. So the padding value, I want to have everything that's not as a core to become the background. So I have to put very low value. You can put anything, maybe minus 2000, because 0 is not correct. 0, by default, 0, it should be black background. But in this data, you can see the intensity over here with the mouse, it's still minus 1000. So if you put padding value of 0, so instead of having the black background, they might get this gray. So it's going to be not really easy, but just put minus, let's say 2000, to the other safe side, that you make sure everything of the data could be padding value of minus this. Click OK. Apply. And then you should now see that they compute the crop and look at the new data. This is a crop form. Okay. If I look on the auto bounding box of the first dataset, right click and select bounding box of the first dataset. Yes, here. And second dataset, also add bounding box. And you can see that I change color of the second bounding box of the crop data to green. Like this. And you can see here the crop compared to the original one. This one is already registered. I mean, they don't change much, and it's not no tilting. But just in principle, if you have like not straight in X, Y, Z, you can go to View here, View on the top, both tab View, and then select Axis to show the principal axis. Like this. Okay. Or can just remove axis. You can also go to Edit again and Preferences. And then in the preferences, edit preferences, and you can see this here. Look at the layout, the second tab here, layout. You can go to compass and click to show compass and select this different type of compass, like the first compass here, maybe, yeah. Yes. Yeah, so you can do like this volume rendering here. This one. Okay, exactly. So you can see that I attach volume rendering, and then I go to here as well. So maybe I can go here and change the color of the volume rendering just to see the difference. This one I go to, let's say, physics. And the first volume rendering, you can make it more or less opaque. You can see that the color inside is been the one that's cropped, because kind of we recenter the core before it's not cropped, and then you can see that some part is a bit bigger than the other. So now we want to work on the crop data, because sometimes you might need to crop even further. Instead of normal cropping, we have this extract sub volume, but here we not only crop, we also do registration as well. That's why we have this volume. It's okay with this? Yeah. Okay. And now we're gonna create some of the porosity. We want to see porosity fraction, and then later we're gonna create log and so on. Yeah. So okay, I remove everything just to get you not too confused. So the first thing after the crop, yes. Yes, you have to click on edit, and you will see the list of the color maps. You just select grayscale. I think you delete it. No problem. Yeah, go to options, load color map, and then select grayscale. Grayscale. Yeah. Come back. And then click here. Go to project, up, and then high object. High object. That's good. Yeah, it's annoying. Yeah, yeah. Now you come back. It's so far okay. Okay, but you can watch. Okay. So now we're going to create two things. First, we're gonna create a mass of this new crop value, because we want to calculate how much porosity compared to the total volume mass, right? So the easiest one to do the mass, you can do auto thresholding. Right click of this crop core and then auto thresholding. Or you don't do, if you don't need to do crop core, you can also just do auto thresholding right away. And you just set auto threshold high, so they will threshold, and you will get the label image. With the info data, you don't need it. You can close the table. You can delete the info. Perfect, no problem. I repeat, just right click on the crop data and then select auto thresholding and select type auto threshold high. And that's it, and then click apply. You will get two results. One is labels, and another one is just table. Just delete it. You just delete the table and close the window. Yeah, we don't need it. And you can see that now I have the, from the thumbnail we create just the mask. Mm-hmm. Yeah, we keep the label. Okay, yeah. Yeah, exactly. That's what I going to show you. We can do, for example, like beam hardening correction. Okay. Yeah, exactly. But this the math is nothing to do with the calculation. Yeah. That's to create the where your volume that you are calculating. Yes. So what we're creating here is just the mass volume that we're gonna work with, because usually we don't calculate anything from the grayscale directly, but we just need to correlate to the mask. And you see that I tend to like organize my workflow in a way that you can see easily where you are working with. And then now with the crop, we can do some image preprocessing. For example, we have background detection correction, beam hardening, or even some curtain artifact create parts. For this example, I'm gonna do beam hardening correction. Right click. So I would admit that sometimes I don't have enough knowledge on this kind of CT parameter. So I admit. So if you, yeah, exactly. But I mean, like if you ask me like how to adjust the proper parameter, so I'm not expert to give you the information. But in Avizo, one thing I want to show you that really good thing, we have the new documentation. You can click on the question mark of every module, so you will link to the new documentation that we have. So I open another doc here. So they will explain what is beam hardening, what they're doing, and the principle, and some example, and the correction, and so on. So explain all the information. And since we are here, so let's go to this new documentation. It's really helpful. So you go to, for example, let's go to extension. So in this extension, you have different extensions. I'm gonna talk about the anything related to PerGeos. So you can go to tutorial. So we have different type of tutorials, and okay, I want to show you where exactly simulation. If you type simulation, yeah, if you type simulation in the search queue, and you can see on the right, we have edition and extension. And click here, you can select extension. And in extension, you can see now we have this XModeling and simulation extension. This is a very important for PerGeos, and then migrate to Avizo. So you can see that we have like digital rock analysis, ganglia analysis, phosphate analysis, and so on. And you look at digital rock analysis, we have many things to look at, two-phase flow, simulation, and if you look at phosphate analysis, we have Pore network modeling, and so on. Yeah, we're gonna work on it, so but don't worry. I just want to show you this is the new documentation is really helpful, and then you can consult it later. So you can also find this documentation by going to Avizo, click on here, and or you can go to help and then click on the user guide on the first one. You will access to that documentation. Is that okay? Just keep that in mind. I mean, it's really useful. You can search and look for anything. Okay, so now I'm gonna do quickly to do beam hardening and click apply. You will get a new result with beam hardening corrected. So as you can see here, quickly from the thumbnail, it's changed. Yeah, thumbnail on the bottom. Yeah, let's see. So I admit I'm not an expert, so maybe I will not see anything on the slides. And then XY like this, and then turn off quickly the beam hardening, and you can see. Maybe I don't see second auto slides. Maybe you have to go to the certain slides to show. Yeah, maybe. Yeah, exactly. So you can see. Maybe I don't see. Okay, so now I'm gonna do quickly the beam hardening and click apply. You will get a new result with beam hardening corrected. So as you can see here, quickly from the thumbnail, it's changed. Yeah, thumbnail on the bottom. Yeah. Yeah. So for example, if I do before, I don't see anything, but do you see any different? Mm-hmm. Mm-hmm. Yeah. And is it correct to do the rotation exit around the set, or should we do on the XY? The rotation axis here, the thing is it better to do on X or Y, or it have to be in the Z direction? Okay, yeah. This thing I'm completely out of the blue because yeah. But at least you know that they have possibility to do beam hardening correction, and I will get back to you more on like proper parameters. So I consult with the PerGeos expert. Maybe I come back to you. Okay. So the point here, I just want to show you there's option that you can do some filter like beam hardening. If you do background correction, you might lose the porosity. I can do that. For example, if I do, yeah. Because I'm not sure if you what you interested here. Probably if you look at this here, if you might see somewhere the porosity is like crack. Yeah, and if you do background detection correction, you might lose it because they kind of averaging the background. So for example, if I do quickly background detection, yeah, but there was some, if you look on the maybe exit, like here, then you see, yeah. So if I go here, oh yeah, then you can see, actually, you can see different of beam hardening between before and after. You can see here and here. Oh, no, maybe because of the, anyway, let's do background detection collection to see if we lose something. As you can see, that be spline. Oh. Yeah. Which one? Yes. So I really want to come back to you on this parameter because I know there's some parameter that you have to correct, and yeah, I need to talk to some of the CT experts to come back to you. What is it? Yeah, exactly. And for example, here I just show you that if you do background detection correction, so before background correction, this is like this, and after you kind of correct the background, I'm not sure is it the right way because they consider this as a background as well. You can see here. Pardon? Top here, right? Yeah. 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 Exactly. Yeah. Exactly. Yeah, that's why I mentioned sometimes it's not necessarily because it depends on the feature you're looking at. So in this example, you want to see the crack actually at this point here. So instead of doing background detection collection, you might not need to do it the same with the beam hardening. It depends on your judgment. So you can see at the edge, even you can see kind of artificial correction on the edge over here as well. The color. I'm not sure if you see well. Yeah. Or maybe you need to first crop here by doing extract the volume to cut this part off. So then you will not have this into account because they try to compensate of what we have before on the pore space over here. So I will just leave it like here because I just you know that you have the option to do many things with Avizo in one place. That's the idea. So here now I want to do let's say to extract this porosity. Let's say this crack here is considered as porosity. So what you could do, you can attach the top hat, interrogate top hat. interactive top hat. If you type top hat, you should see interactive top hat coming up. Double click. So it's the module here. Interactive top hat. Okay. So interactive top hat, they have two steps. Is the you can see at the bottom of the module they have two steps, step 1 and step 2. So we are at step 1. We have to select is it white top hat or black top hat. So you want to see the black porosity, and so I just change this interactive top hat to accept, let's say, and turn off this auto select. So this is my interactive top hat module with the preview on interactive top hat. So select black top hat, okay, and that's it, and then select next. Now they compute the top hash image. So first they do grayscale closing, and then they subtract the closing image with the original image, so you get the top hat image. So you can take a look at top hat image here in the middle here. Top hat. You can see the top hat image here. This is what subtract from the top hat. Is this okay? Yeah. Okay, so I will explain really easily. First thing, you look at this image here like this, and so the first operation in top hash image, you have to do grayscale closing. Yes. Yeah. So I'm gonna do right now. So first, you do the closing on the grayscale. Yeah. Yeah. Fracture. Yeah. That. Yeah. So now, first thing to explain top hat. First thing you do closing. So right click and select closing. Only closing. You see this module. What we're gonna do? They're gonna close this image. So click OK, apply, and you look at the closed image like this. Here, before and after closing, you can see they do grayscale closing operation. And now I'm gonna subtract this image to the original image here. And whatever you get from this subtraction, you will get so-called a top hat image. Okay. So I'm gonna do by select here and then select subtract image. So attach module subtract image. So this image subtracted to image 2 here. Again, image this one closing subtract to the original image. So, and I get the final result. Let's look like this. So it's subtract image, and then you look on the auto slide. It's exactly the top hat images that I created. Like this, you can see easier. So it come up the kind of intensity. And now after this, you're gonna attach interactive thresholding to this image. Sorry, interactive thresholding. And with this interactive thresholding, you can start to threshold this top hash image, like here. You can see that coming up, the porosity. That you can see that I do two operations. First, I do closing, and after closing, I subtract the closing result to original data, and after that, you get the so-called a top hat image. And after that, you apply thresholding to the top hat image. So actually, if you do this, you can need 3-step operation module 3 times. But what I'm gonna introduce to you, instead of doing 3 things here, closing, subtract, interactive thresholding, you can easily do a module called top hat, interactive top hat. Okay? Yeah. What do you mean? Can you repeat? I cannot. Yeah. So now we can start with this result from the beam hardening. So right click and select or type interactive top hat. So and then select in interactive top hat to extract maybe to see better. So you want to extract the porosity inside of this core. So what first we need to do grayscale crossing and subtract the image. So that's what we gonna create the top hat image by select black top hat and then click next over here, next. At this step we apply crossing followed by subtract image. So look at the top hat image over here in the middle here. Top hat image and adjust dynamic range a bit. You can see that now it can easily see where the porosity has been coming up. The next step is you have to adjust the intensity range. It's exactly the interactive thresholding at this point here. So I move the thing here. So you can start to pick up this kind of porosity. Okay. Yeah, but it depends because sometimes this could be, actually we are interested in the porosity than the fracture. But it depends on what you like to see, because but what we capture here is the intensity of what's so-called porosity. In fracture, you can remove them later with the filter by measuring, for example. Yeah, because the fracture, if you want the fracture be big, yeah. So what I could do, for example, I do like here, and because usually the fracture is continuous and then it's bigger, so you can do later by let's say, for example, I do it like here. Okay, let's say everyone follow any questions so far? Okay. So they have many ways to remove what you're asking. So for example, you can remove small spot, for example, remove islands, or you can use filter by measurement. Have you tried the remove small spot? Yeah. Yeah. No. Yeah. Later. Yeah. Yeah. Exactly. Any questions so far? Yeah. Yeah, exactly. So it depends on you. So yeah. Yeah.
We can discuss if you like.
Sure.
But just
Yeah. Yeah, exactly.
because I can later you can use build template.
Yeah, sure. Yeah, sure. Yeah. After.
Then you can IP segment very well.
Mhm.
This is what
Okay.
And there are very range and resolution how you can do the same
Mhm.
sample.
Yeah.
And you can pick from the refine to the report.
Yeah.
And then you can also, there's a wall, because I realized that we will time.
Okay.
I imaged the wall.
Yeah.
So if you want the available.
Sure. I will check it because I didn't. Yeah. So let's focus on top hat image here. What we would like to achieve from top hat operation, you want to segment so-called porosity, like because in general, when you do normal interactive thresholding, you cannot be able to segment this kind of porosity, or it's gonna take more steps. But with the interactive top hat, you can easily segment of this kind of porosity or even crack. So click apply. So if you look on this result here, or not here, that's why. Yeah, so the result from top hat, this one, turn off the top hat. And now you can visualize them with volume rendering, for example. You can see that. Yeah, because of the way we crop is not good enough, because you can still here, you see thing here. Yeah. Border queue. Yeah. Yeah, you have to click apply 2 and 2. So top hat, you have 2 steps. Like step 1, you have to select black top hat. Yeah, and then next. No, when you click next, before you apply, you have to adjust the intensity range first. And what intensity length? You should see something like this before you click apply. You see something like this. Yeah, and then you click here apply. Yeah. Then apply 2/2. Yeah. And then you should get the top hat image. And you can see already from the 2D, that look like this. They have something coming up on the edge. So yeah, you have to do. Anyway, this is just pure porosity. And if you want to calculate the volume fraction of this porosity here, let's say if I have this volume here, and the previous mass that we created, yeah. So if I create volume mass in different color, and you can see here, for example, if I have this volume mass in purple, and the blue is the porosity of crack, and now you can create volume fraction. So let's go to volume fraction. So you go to the result from top hat and select volume fraction, and then you have to select the mass, which is the here, the label, the blue mass here, the whole one that I do auto thresholding is the mass. So you select the mass from the here and apply, then you get the volume fraction. Just auto thresholding, the one from the result from auto thresholding, there's a mass. Yes. Okay, I come. I know there's some. The what?
So when you use volume fraction, it's just to divide between.
Yeah, for example, like you create the mass, the whole volume, and then you do top hat just to segment only the porosity, and then you just see how much of the porosity inside the total mass, because total mass is solid full volume, like 100% the total mass, and the porosity that you expect from top hat is just maybe a fraction of them, maybe 20-30%. So you can even do manual calculation, but just the module that just do the job. So you need to make sure that in total 100% mass, how much of porosity inside compared to full volume. Yeah, we can just attach volume rendering. You can see that, and you can see the pore, and you can even label them to have different colors in the pore. Yeah, that's okay.
This looks a lot.
Yeah, exactly. Yeah, okay. So that's the quickly volume fraction, and now we can do is go back to everything. So let's start from the beginning, because now it's just only calculation, but now I'm gonna show you how you create logs and everything. The easiest way to start, you just go to File and New Project. No, it's okay. Yeah, I just now gonna go to something more easy, because now I think it's a lot and you're getting confused. So go to File and select New Project, and then just discard this, or you okay. File, New Project, and discard. Okay, now it's empty. So File, go to File here on the top, and then select New Project and discard everything. Okay, it should be really fast. Yeah, some like heterogeneity. Yeah. Yes. Yeah. 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 This one. Volume fraction. Yeah, it's 27%. You have to times this volume fraction with 100. Yeah.
This is what I'm but I think we just selected the wrong.
Yeah.
Later we need to be.
And also, usually you should
precise.
do some more cropping, like extract the volume, because here it's so it's not the zero. Yeah. You have to do more cropping if you need to. But this calculation is just like to see how much percentage in the total volume.
beginning we will like the same.
It depends on if you have like porosity. Sometimes if you apply filter, you might lose the information of porosity. It depends on type of porosity. If you see that filter it reduce or is closing the porosity, maybe because of the effect. Yeah, you have to, it's very subjective to you. That.
Yeah, so some is we cannot
Yeah, exactly. If you have very small porosity, and then if you do the blurring like median filter, box filter, you might lose or because it kind of evaluating the intensity. So it depends on the data what you're looking at. Especially the porosity that may be important in you. That's why maybe you can directly use top hat directly instead of median filter or sandbox filter.
this one pattern can be used in the philosophy.
Yes, yes, yes,
So
exactly.
the new one is just about
The top core, exactly.
Yeah, because I remember
Yeah, exactly. Yeah, and so if you want to start like here, go to file, and then Control N or new project, and then you discard everything. Yeah, yeah. We will start it. No. So you need to get used to it, and then you go to start, and then you can just select open the same data. This is the easiest way to start from the beginning. Okay. Okay. So we will start from the beginning again, but this time we're gonna create logs. So go to start and you select the previous core sample. And we can open more data as well. Where is it? Go to this folder one more time to open more image. Here. So you can see that it have folder in the digital rock, core profile. You can see that we already have some prepared data. So we have the crop and the fake borehole, fake photography. So open this. Yeah. The first one.
Okay, this is why I wanted to also to update the video because you have two sections.
Yeah.
To see how you speak
Okay. So
before going to the.
okay. Okay, then fine. Let's start. You can remove it. You can delete it. Okay. Okay. As you request. Okay. Let's first go to this digital rock data. Here. Crop profile, and you want to see the assembly. Okay. Click on the assembly, and select these two. Here, and you can open it to drag to Avizo, and I share. There. So you should have this view and attach volume rendering to each of them, like this. Okay. Do you get this view? So you can change color as well if you think it would help or whatever you like. For example, if you change this color to, let's say, green, and this one to red, orange, red. I don't know if that makes sense. Let's go to. No, it depends on the coordinate that they from the beginning. I think this is a fake thing that we just make it a bit close to each other. We register it to make it more easier for you. Yeah. So what we're gonna do here, we're gonna do image registration. So let's start from. You can select one of the core to start to modify them. So I visualize them like this. Okay, let's say I will start from the one at the bottom. doesn't matter which one, but I think they are already very close. You just need to align them very well. And in Avizo, they have these two viewer. It's called perspective view and orthographic view. You can see here, orthographic or perspective. It's very important for registration or volume edit because why? I can show you by right click on bounding box to show you quickly how it looks like in both view. If you attach bounding box by right click and select bounding box for both data sets, you can see that both bounding box maybe change one color differently. Like this. Okay. So you can see that by default we are on perspective view like this. It's never been completely overlapping because of it projects. So it projects perspective. To do any volume edit or thing, you should go to the perspective. When you're on the perspective view like this, so you can see that it can completely overlap. We give you exactly the same dimension. Otherwise, you might not see good judgment of your data. So instead of you see the projection like this, you can see that they might completely fit. But if you change to orthographic view, you see the real dimension of the data set. So now what we can do, we can go to bring maybe the bottom one with the orange bounding box to the green bounding box. To do that, just click on one of the data you would like to modify. Yeah. Okay. No. Yeah. At the moment, no. I can ask. Okay. Oh, okay. 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 Yeah. Sorry. So yeah, in Avizo you can actually do by you can do here. It's called the manually and then register image. Okay. So now you understand. But it's possible. But we have, for example, now we need to do image registration. The principle of image registration here, first you need to do the transform editor here. Click on one of the data. Let's say I click on this data and do the transform editor here. And when you transform editor, you can see this thing coming up. You have to change from the hand tool to interact tool to the arrow tool. Then you can bring them close to each other like this. And see, you can bring it anywhere. But what I'm doing here is just only visualization. It's not the real moving the data set. The coordinate of the set is not changed. It's only changed in the camera view. So what I'm gonna do now, I'm gonna apply register images. So right click on one of data and then select register images here, and then you can select the reference or change a different reference like module. And you can see that in the register images you have model and reference, and then we have different transformation as you ask. So if you don't have any shear, you can just select a register transformation and then you click apply. They start to register the object like this automatically. Okay. Once it's registered, then you need to merge them. So right click on one of the data set and then select merge. So with new data merge, so you get the kind of data that already it's kind of manual work, but yeah. So now if you attach the bounding box in maybe in red, you will see the new object here. Is that okay so far? Like this. So look at the new data set. Yeah, so you need to use register images, but it's more fine tuning. You can do many things if you have some shears or some, I don't know, some train in the data. That's the request, okay? Yeah. Yeah, because it's already in Avizo for a long time, and then yeah. Now, yes. Oh, okay. Okay, maybe 10-15 minutes just to finish with, because we don't even go to the core profile workroom yet. But but anyway, just let's go to this folder. So now we go to core profile and open this, all of them. Like you can select here and open in Avizo. Okay, core profile, and select this core sample, fake borehole, fake photography, image analysis, and Pore measure, and put in here. Then okay, and you just get the open. So go to, yeah. So usually you see that this is the crop core that is already cropped like this, and we have also some image analysis. So I can also create a new image analysis as well. So go to this crop core here, and then right click, select the heterogeneity log. This one, heterogeneity log. And you can see here by default is number of logs, is the range. So as you can see here, then at the range, they have this histogram, the peak on the dynamic range. So if you select number of logs 5, they will split this range into 5 range for 5 logs. Yeah, based on this limit. Okay, it equals. Yeah, this is okay. And then you click apply the heterogeneity logs, and then you should get the log file here. Okay, this is done in the project workroom. So now I have everything. Okay, that's the point. Now we go to core profile. Finally, this is the workroom here. All done? Yeah, core profile. That's yeah, core profile. So it becomes like a new workroom in Avizo. It's the same like Avizo or PerGeos, but it's still directly. You can do anything on the image processing, image visualization, image processing statistic in project workroom. But if you want to visualize core profile, you can go to core profile. In core profile, on the data here, just select the CT sample, so that's the one that's cropped. Now it's open, and you can see zoom in, zoom out. You can see here where you can select the section you want to focus in. Yeah. Okay, and change to here, and then show the depth, and then you can select the photograph. That's why we load the fake photography next to the core, and then you can also select the borehole, fake borehole as well. The parameter, it's already from this one. It's just something sample data set that I created. Okay, you mean the logs? Okay. So to visualize the logs, okay, maybe I just remove the borehole like this, only 2. So now I'm gonna look at the logs. So if you look at the data here, the chart properties, you can drop down. So they have like pre-sample, but the one I just created the heterogeneity log, so you can just select the heterogeneity log. Yeah. Sure. Yeah. Okay. Yeah. Okay. 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 Okay, then this comment I will just ask the developer if there anything improve on this point. So for example, now I select the result from the heterogeneity log that I created before, and you can see now we can here I load the heterogeneity log, and then the log you can show the log because I have 5 sections, so they have depth from -4 whatever, but you can also select to display all logs as well, like this, and the logs will be up here. because I have here the section that I want to visualize logs, but you can also increase. Yeah. Yeah. And you can go to logs. Yeah. Or you can remove photography quickly. So you can see a few logs, or you can remove some logs that you don't want to see, or change the color of the logs. Log from the depth, because I created a project workroom here with the heterogeneity logs. Just so you split this range into 5 logs, but if you, let's say, if you do one like 7 logs, but you can visualize maximum 6 logs only. But yeah, you have to select like which 6 logs you would like to visualize. So then you can display all logs and display all logs, and then you just maximum 5 or 6, and then you can remove. You're correct. Number of logs. Yeah, exactly. It should be 5. And then I click apply. Yeah. Number of logs. Number of bins of histogram to retain. Bins are equally distributed along the core, the city intensity, and the range. Yeah. Yeah. And then go back to core profile. So now if I would like to display all the logs, we can also change color of the logs, and to display on here, you can also uncheck to not display some of them, or like this, so you can see the log. And this question so far at this point, I think now people with PerGeos should get familiar all the features, right? And then we have these on the right. So from top to bottom, look quickly. So we have this band extractor. So you can also extract the band based on here. For example, if you change this band over here, you can see when I change the bounding of the band, bounding box of the band, you can see here. If I go somewhere here, you can see the value is moving, right? And if you click extract data here, they will create a new file in the project workroom. So you get this, where is it? The extract here. So it's just only the shorter part. So this is from the band extractor. Is that okay? It's clear. So you go to profile, you can just select extract whatever band that you just define with your own value here. You can see value. And now come to XY viewer. You can see XY here, the XY viewer, see the XY plane for profile. You can, and so select orientation of the viewer. And they are look at the cylinder. So you can also look at the cylinder angle. So let's say go to XY plane. CT of the cylinder, like this. So it's kind of project from the crop of the cylinder. And you can see, look at the angle of the cylinder to be project on this view. Remove lock quickly. Yeah. No, it's like project from the outside, like the borehole image. Yeah. Yeah. So if you go, for example, if I go like here, you will see. Yeah. Exactly. Okay, and you can change the radius because you can see that now because of the radius is quite big, and you can see on kind of how you say like the black streak here. You maybe reduce the radius 60, and you can see that now the images you see it's been cropped because when you have 65, you see the radius is get everything maybe somewhere even some porosity outside or like the rugosity of the surface. You can see this kind of the black streak. That's because of the radius. So I changed maybe from 65. I changed to 60, and you will see that the radius has been only on the inside, and you can see the total. Yeah, it's similar to flattening as well. I mean, not flattening, but more like a panorama. Yeah, exactly. Yeah, similar to flattening. Yeah. Okay, and then you can select overlay. Before, if you create the porosity, you can also overlay the porosity in this image because we didn't create any porosity. I do quickly. Interactive top hat and black top hat. Next. For example, if I just quickly create this top hat, and if I here and adjust porosity like this. Yeah, like this, and apply. So I should have the porosity overlay. On the overlay here, just select top hat. Oh, no. What happened? Not sure what happening here. No, because the image is gone, so maybe I can try. That's strange. Maybe yeah, exactly. Strange. Maybe some. Oh, okay, then let me take a look at maybe something that I did wrong with here. Overlay CP cylinder. Okay, I will just restart it. Still, I'm not sure why. Ah, okay, I think. I don't see the. Doesn't work anymore. Strange. Yeah, I think maybe we can take a break. Just finish for today, and tomorrow I come back with the. But if you have any questions, so we still have time this afternoon, you can also come to see me one-on-one. Yeah, it'll be easier.